Hello class. So this is video 3 on section 4.7, L'Hopital's rule. So what is this theorem? So in the previous videos, we saw how to use L'Hopital's rule. We have to get an indeterminate, which is something of the form 0 over 0. Right? We also saw that we can use L'Hopital's rule as many times as we want, as long as we get an indeterminate each time. Okay, so that's what we did in the previous example. Here, this is the same thing as the previous theorem about L'Hopital's rule. The only thing here is that we add a new indeterminate, right? So far, the indeterminate forms for us. So this was just 1, right? This was just 0 over 0. This theorem says we add one more. If we have plus or minus infinity or divided by plus or minus infinity, this is also an indeterminate. So what does that mean for us? Well, if we're taking the limit of a quotient, and instead of getting 0 over 0, we get infinity over infinity when we evaluate each limit separately of the top and the bottom, we can still use L'Hopital's rule. Okay, so that's the idea here. We add one more indeterminate. Okay, let's go ahead and see an example. We want to find the limit as x approaches infinity of e to the 3x divided by 3 e to the 3x plus 5. Okay, let's write it out. Limit as x approaches infinity of e to the 3x divided by 3 e to the 3x plus 5. Okay. Now, if we take the limit of the top and bottom, right? So it's okay. Let's see. Can we use L'Hopital's rule for this limit? Okay. So let's take the limit of the top and the bottom. So limit as x approaches infinity of e to the 3x divided by the limit as x approaches infinity of 3 e to the 3x plus 5. What do we get? Well, remember what the exponential looks like. Remember the exponential graph. Let me graph it here real quick. The exponential graph looks something like this. So it's going to infinity. Now, the fact that we're multiplying by 3 on the x just means that we're either stretching or compressing vertically, horizontally. But it doesn't change anything about the long run behavior. As you make x values larger, your function gets larger. And it makes sense, right? Take e to the 100, well, e to the 200, e to the 300, that's getting bigger and bigger. You're multiplying e by itself 300 times, or 400 times, or 500 times. So it's getting bigger, right? So the limit of the top is infinity. And then for the same reason, on the bottom, we also have e to the 3x. Again, if you plug in larger and larger values of x, that's going to grow larger and larger. So the limit of the bottom is also infinity. Now, based on the last theorem, if we have a form, an indeterminate of the form infinity over infinity, we can use L'Hopital's rule. Okay. So what does that mean for us? We take the derivative of the top and the bottom. By L'Hopital's rule, look at the limit instead as x approaches infinity of the derivative of the top. Remember the rule, just bring the constant out, leave the rest the same, divided by the derivative of the bottom. So derivative of 5 is 0. What's the derivative of 3 e to the 3x? Again, just bring the 3 out front, right? So we get 3 times 3 is 9 e to the 3x. This we can simplify, right? Not evaluating anything yet, just simplifying the expression. I can cancel out e to the 3x on the top and cancel out e to the 3x on the bottom, right? So what do we get? Cancel those, we get limit as x approaches infinity of 3 over 9. This is the limit as x approaches infinity of 1/3. That's a constant. We know that the limit of a constant is just a constant itself. So what does this mean? The original limit equals 1/3. Okay. So again, same thing as before. The only difference is that we added a new indeterminate. Right? So we had 0 over 0 before. Now we see that infinity over infinity also works. And it doesn't matter the signs of the infinity. You could get plus infinity on the top, minus infinity at the bottom. It doesn't matter. As long as you have infinity on the numerator and the denominator, whether it's plus or minus, it's an indeterminate. You can use L'Hopital's rule.